Okay, hi. So I showered. You're welcome. And got more coffee. So I want to continue the thought of numbers just before I completely forget to finish the idea, but I'd reached 10 minutes and I didn't want to do that. This is what makes math so fun in my mind. And there's layers and layers and layers and layers. So most of the numbers that children ever deal with are in the realm of rational numbers. Okay, what you talked about is ratio. So the set Q is rational numbers, and it's any number that can be written as plus or minus a over b. Okay, those are rational numbers. To contrast, they're irrational, which essentially means that you cannot be written as plus or minus a over b. Okay, you can't. So let's just take a little moment and talk. Here comes fractions. Obviously, this is a fraction. It's a rational number. It's a ratio. It's a quotient. It's division. The thing about fractions that they tell students is it's a number and an operation all embedded in the same time, which we're going to talk about when we talk about our operations. And we'll probably do one video on each operation, 5 to 10 minutes long. So I want to take you down a road for two of the most incredible irrational numbers that you use all the time. How you can know, like, finally know this and not have it blow your mind about like our world and our existence and their meaning and life, and it's like so you can Google search this. There's legends on a lot of these things. Hippasus is a dude with square root of 2. We're going to talk about this for a second. So let's take a sidebar. This is still numbers, but let's just take a little journey in irrational numbers, and we're going to take just a hot second to be in the world of geometry. Okay, two shapes everybody knows. Okay, when you're a little kid. Okay, and in fact, it's very simple. Can you put a square peg in a, you know where I'm going, round hole? Okay, so here's a square, and this, of course, is a circle. Two of the most important irrational numbers come from these shapes. Now remember, irrational only means you cannot write it as a fraction. It is endless. Okay? The number never stops. It never repeats, which we're going to talk about more when I get into decimals and division. Okay? So remember that. When we talk about division, just remember numbers that never end, but don't repeat. Because repeating numbers can be written as a fraction. For example, 1/3. We all know from our time in math class, if you put 0.3333 in a computer or a calculator, it's 1/3, right? Because 1 divided by 3, if you remember long division, just repeats. So, but it still can be written as a ratio. It's not irrational. Irrational numbers are decimals that never end, and they cannot be written. But the two most famous ones come from these incredibly simple shapes. And if we're really truly doing geometry, that's for another lesson, but I got to do it. The math person in me cannot do this without having my symbols. That's a square. This is a circle. Now, most people like to talk about pi. I prefer tau, but tau hasn't taken off yet. But pi is the ratio. It's comparing the radius, right, to what happens in this whole circle. Okay, and we actually can use polygons to approximate pi closer and closer and closer and closer and closer. Pi is a number that never ends. When I was in 8th grade, I sat in the back of the class, and there was a that my teacher had done, and I just happened to sit near it, of pi. And I went 3.1415927, I don't remember after that. And it just kept going for page after page after page after page. And I was like, pi is a number that never ends, but it is basic to a circle. It is an infinite number that is held within our most common shape. And we usually just approximate it as 3.14, right? Because those are the only statistically significant digits you need. The other major irrational number comes from a square. And we all know, because of the Pythagoreans, can you remember it yet? I know I'm jumping around because I'm getting all the lessons in, but these are awesome. Remember, if it's a right triangle, then the sum of the squares of the legs equals the sum of the square, or the square of the hypotenuse. So in a square that has units 1, here's the hypotenuse. So a squared would be 1 squared, right? Let's say this is a, b, c, right? 1 squared plus 1 squared equals c squared. So 1 is 1 plus 1 equals c squared. 2 is equal to c squared. C is equal to the square root of 2. Now, legend has it that, and we can talk about the proof of this another time. Like I said, we're going to do a little teeny bit of number theory because it's fun. Legend has it that Hippasus, the Pythagoreans believed all is number. So every number could be written as a ratio. That's what they believed. Okay? It was like, it was a religion. It really was. That's what they believed. And you can learn a lot about music, especially stringed instruments, from the Pythagoreans. And like the ratios and the harmonies, it all comes from that. And what's fascinating is watching my son learn to play the cello, and it's just like, right? But so Hippasus, people tried and tried and tried and tried to make square root of 2 into a ratio. They couldn't do it. So Hippasus proved that it can't be done. It's not possible. And, I mean, I can do that here in a different thing as like a sidebar. If people are curious, you can Google search it pretty easily. Because it can't be done. And legend has it, the Pythagoreans freaked out and killed him. Because they were just like, it shattered their worldview. So if you think people are shattered now, they were then also, right? Okay, so that's a little sidebar on rational and irrational. Irrational numbers come up a lot in geometry. A lot. That's why it's always this like reminder in math class. And little kids, they start to deal with fractions, right? And those are rational numbers. And I genuinely don't remember the scope and sequence of a lot of really little how we start to count, but we can do a sidebar on digits of like how we do our digits. All right. Stay rational, everybody. Except for irrational numbers are really beautiful. Because obviously, square root of 2 ends. Or does it? Closer and closer and closer. Asymptotes. But we don't get there. All right. Stay safe, everyone. Happy quarantine.